Hi guys, and welcome to Introduction to Mechanical and Automotive Engineering. I'm your lecturer, Dr. Elizabeth Kyriakou, and now we're in week 3 of semester, and we took a look at the first video looking at structural analysis, and we identified in a truss which were members and which were joints. So now we're going to actually look at the force in each member of a truss using method of joints. So I think the best way to do this is to actually take a look at an example and analyse the forces in a truss. So here we have method of joints. And let's take a look at this problem. So here we have a truss and we have members AB. Here we have AB, BC, AD, CD, and we have BD. So we want to be able to find what the force is in each of these members. But before we can do that, we need to make sure that this system is in equilibrium. And how do we do that? We can use our equations for equilibrium, and at A we have a roller, so we know we're going to have an AY, and at C we have a pin joint. There we know we're going to have two forces, a CX in the horizontal direction and a CY in the vertical direction. So the first thing we're going to do is we're going to draw a quick free body diagram, and step one is to determine what our reaction forces are. So find reaction forces. Okay, let's draw a free body diagram. So here I have my truss, and it's A, C, and D. So we know that at D we have a force of 45 kilonewtons. At C we're going to have two reaction forces, CY and CX. And at A we're also going to have a reaction force, and it's going to be AY. So what else do we need to include on this free body diagram? We need to put some dimensions on. So from A to D we have 2 meters, and we have another 2 meters, and the height of the truss is also 2 meters. Okay, so here we have our free body diagram. We need to identify our X and our Y axes. If I have two unknowns at C and one at A, I should be able to take some of the moments around C to determine AY. So let's write up our equations for equilibrium. So we have some of the forces in the X direction equals 0, some of the forces in the Y direction equals 0, and some of the moments around a point has to equal 0. So let's take some of the moments around C. Some of the moments around C has to equal 0. And which way are these forces going? So AY is going to go around C in this direction, and D it's going to go in this direction. So that's going to be negative, and that's going to be positive. So we're going to have minus AY, and the perpendicular distance to C is 4 meters, plus 45, and the perpendicular distance from D to C is 2 meters. So we can solve for AY. So AY is going to equal 22.5 kilonewtons. So now when we want to find CX and CY, we can take some of the forces in the X direction and some of the forces in the Y direction. So let's do some of the forces in the X direction has to equal 0. And what do we have in the X direction? We have minus 45 kilonewtons plus CX. So CX is going to equal 45 kilonewtons, and we assume the direction to be correct. And then some of the forces in the y direction is going to give me AY, which we calculated earlier, minus CY. So CY is going to equal 22.5 kilonewtons. Okay, so we should all be feeling very comfortable about trying to find the reaction forces in any structure at the moment. Now we have our system is in equilibrium. Now we can take a look at how to calculate the forces in each member. So I'm just going to clean this up and we're going to draw a new free body diagram. And I might just leave our equations for equilibrium because we're going to use them again. So step 2 is find the force in each member and state whether it's in tension or compression. Okay. So let's draw a free body diagram. So here's our free body diagram. And we have a truss with all our members. So here we have A, B, C and D. And now we need to include all our forces to ensure that our system is in equilibrium. So here we have AY, and we know that is 22.5 kilonewtons. At CY, it's also going to be 22.5 kilonewtons. CX is 45 kilonewtons. And we know that at D, we have the applied load, which is 45 kilonewtons. So now what I want to do is I want to find the force in each of these members. So I want to find the force at AB, BC, CD, BD and AD. So let's now take a look at the method of joints. And what we're going to do is we're going to start over here at joint A. So at joint A, let's draw this up. Let's draw another free body diagram at joint A. So here we have A. I'm just going to draw in a little axis. So at A, I know that I have 22.5 kilonewtons, so I'll just draw that in. And that was my AY. So what else do we have at joint A? We have this member here, AB, and we have AD. So force is a vector, so it's going to have magnitude and direction. We have the magnitude, but now we need to specify what the direction is, and the direction will come out to be in either tension or compression. So in all these problems, I always assume that my members are in tension. So if my result comes out negative, then it means that my member is going to be in compression, but the magnitude will always be the same. So let's assume all members are in tension. So if all my members are in tension, it means that I'm going, here is my joint at A, I'm going away from the joint, and the same with AB. So just for quick reference, here is my joint. If I go away from the joint, then I'm in tension. And here is my joint again. If I'm towards the joint, then my member is in compression. Okay, and this is something that we need to remember when we're doing method of joints. So I'll just clean this up and let's solve this problem. Okay, so if I look at this problem here, it's equilibrium of a particle. So I should be able to resolve the forces in the x and the y direction to find what my two unknowns are. So what do we need to do with this AD? We need to turn it into horizontal and vertical components. I know this angle is 45 degrees. So here I'm going to have AD sine 45, and here I'm going to have AD cos 45. So let's use our equations for equilibrium and determine force. So if I take some of the forces in, let's do the y direction first actually, because I have less unknowns in the y direction. So some of the forces in the y direction has to equal 0. So what do we have in the y direction? We have 22.5 kilonewtons minus AD sine 45. So I can solve for AD, and AD is going to equal minus 31.8 kilonewtons. Okay, so now we assumed that this member was in tension, but we've come out with a negative number, so that means my member is in compression. So the way we would write this is AD equals 31.8 kilonewtons in compression. So if I go over here, I can actually write 31.8 kilonewtons in compression. So now we know what AD is. Now we can take some of the forces in the x direction to find AB. So some of the forces in the x direction has to equal 0. And I'm going to have AB is positive plus AD cos 45. So we can write this as, we're going to solve for AB, so AB equals minus AD cos 45. Okay. But earlier we wrote that we assumed that AD was in tension. So we need to remember that we need to include the negative sign when we are substituting AD into this equation. So we're going to have equals minus 31.8 kilonewtons cos 45. Okay, so AD is going to equal 22.5 kilonewtons, and that's going to be in tension. So we can write AB, So AB here is going to be 22.5 kilonewtons in tension. Okay, so now we found out what the force in the member, and we identified whether it was in tension or compression of AB and AD. Now to find the other members, we need to take a look at the joint at C. So let's take a look at joint C. Okay, so let's take a look at joint C now. So here is joint C. So let's draw a free body diagram for joint C. So here is C. I'm going to draw in my X and Y components, and I should actually have drawn in my direction for X and Y to make sure we know which way is positive and which way is negative. And at C, I have two reaction forces. So we'll draw those in first, and that's 22.5 kilonewtons and 45 kilonewtons. So at C, we have member BC and CD. So here, I'm going to draw my member for BC and the member for CD. Again, we're going to assume that everything is in tension, so that means my forces are going to go away from the joint. Alright, again, we need to break this CD up into horizontal and vertical components. So we'll have here CD, and that's 45 degrees, CD sine 45, and CD cos 45. So if we want to resolve our forces in our X and Y direction, we should be able to find what the force is in each of these members. So we'll start with some of the forces in the X direction. Has to equal 0. What do we have in the X direction? We have a positive 45 kilonewtons minus BC and minus CD cos 45. So here I have actually two unknowns. I have BC and CD. Let's take a look at some of the forces in the Y direction and see if we can actually eliminate one of these members. So now we have some of the forces in the Y direction has to equal 0. In the Y direction I have minus 22.5 kilonewtons plus CD sine 45. I can now solve for CD. So CD is going to equal 31.8 kilonewtons, and it's come out positive, therefore it is in tension. So now if I substitute this value back into this equation, we can say that 0 equals 45 minus BC minus 31.8 cos 45. So BC is going to equal 22.5 kilonewtons in tension. Okay, so now C, we can write it up here, 31.8 kilonewtons in tension, and BC is going to be 22.5 kilonewtons in tension. Okay, so now we only have one force left, and that's PD, so we need to take another joint and look at C. So let's take a look at joint B. Okay, so at joint B, let's draw a free body diagram for B. So joint B, we have B here, let's draw in some axes. I know that at B, I already have two forces that we know. Let's write that in here. I've already assumed that they're in tension, and that's 22.5 kilonewtons, and that's 22.5 kilonewtons. And the only force I have left is BD, we need to assume the direction. We always assume that it's in tension, so it's going away from the point. And I can draw my arrow. So, if I take a look at this, the sum of the forces in the x direction need to equal 0 for my system to be in equilibrium. So if I do sum of the forces in the x direction has to equal 0, I'm going to have minus 22.5 plus 22.5, and therefore sum of the forces in the x direction is equal to 0. So therefore, I know that in the x direction, I am in equilibrium. Let's take a look at the y. So sum of the forces in the y direction has to equal 0. And the only force I have in the y direction is BD. So therefore BD is equal to 0. So what does this mean? This means that BD is a 0 force member. So that means BD is neither in tension nor compression. So no tension, no compression. And what does this mean? It means that this member is used for stiffness in the truss and stability. Okay, so now we've taken a look at the method of joints to determine the force in each member of my truss. So take a look at some tutorial problems and see if you can solve the problems on your own.